Today's video is on lesson 1.4, graphs of proportional relationships. Now, this video is going to be a little bit different. We're just introducing lesson 1.4 to you today. And instead of having a video note sheet, we want you to follow along in your math workbook. So please make sure you have a pencil, you have your math workbook all set to go, and a calculator. All right, let's start out with the I can statement on page 31. I can determine if a relationship is proportional by analyzing its graph and explain what the point 0, 0 and 1, r mean on the graph of a proportional relationship. Now, most of us know, and you might want to make a note of this again, just in case you forgot, that the point 0, 0 on the graph is the same thing as the origin. We refer to that as the origin. We're going to look a little bit more at that once we get into some of the examples today. The other thing we want to take a look at is the point 1, r. We're also going to take a look further at this as well, but if you think about it, most of the time what we've been doing in this lesson is taking a look at what does 1 of something mean? And 1 of something always refers to the unit rate. So again, we're going to look deeper into this in the examples as we go along today at what 1, r means as well. All right, now that we've finished the I can statement, let's look a little further down the page at the learn section. And you can underline, or if you want to highlight these things, you can too. So basically a graph with a proportional relationship, it's a straight line that goes through the origin, okay? A graph of a non-proportional relationship is not a straight line, or it's a straight line that does not pass through the origin. So if you look down further, I'm just going to go back to green here. This first graph would be proportional. It goes through the origin, and it's a complete straight line just like that. And let's go back to red here quick. The second graph is not proportional. It is a straight line. However, right here, you can tell it does not go through 0, 0 or the origin, and that makes this not proportional. All right, so why don't you take a look off to the right? I know on this slide it got cut off a little bit right here, but this is where it says talk about it. Why don't you go ahead and read that question to yourself and kind of think about why does a proportional graph have to be a straight line and pass through the origin? All right, so hopefully what you're thinking is that when a graph is a straight line, it has a constant rate or a constant ratio. And we've talked a lot about that in the past few lessons, having a constant ratio, right? So as it goes up at the same rate, that's what's going to, when you graph it, it's going to form a straight line. All right, let's turn the page to page 32. Let's go through our first example right here. If you looked at this table up top, it's talking about a rabbit challenges a tortoise to a race. The table shows the distance. We have the minutes, and we have the distance measured in feet. So what we want to do right now in part A is we're going to graph this relationship. So I'm going to zoom in just a little bit here. And the first point would be 0, 0, which would go right on the origin right here. The second point would be at 1, 6. So we go over 1, up 6. So go ahead and do this in your workbook as well. Then we're going to go 2, 12, which is right there, and 3, 18, which would be right there. When you're finished, what we can do is we can draw a straight line right through there. Just do the best you can to make a straight line. Okay, and now we need to describe this relationship. The line is straight, and it passes through the origin. So this is a proportional relationship. It starts at 0, 0, and it goes up at a constant rate, right? So if you look here, the other thing I want to point out from the I can statement, I know this is probably not until we get to lesson or example number 3, which we're not going to get to today. This will be tomorrow. But as long as we have the table here, I want to point out two things. If you guys remember from the I can statement, they said, what is the importance of 1, r? Now on the table up here, I'm going to circle 1, r, and that means that the, that the tortoise moves 6 feet in 1 minute. So another way to say that is 6 per 1, right? So 6 feet per 1 minute. And that's how we get our unit rate. And again, if we looked at it on the graph, I'll just use a different color here. That would be this point right here. Okay, so again, just referring to that 1 comma r, again, talking about the unit rate. All right, now if you go to the bottom of page 32, what I want you to do is take a look at this check. I want you to read through the problem, graph this situation, and then describe their relationship. So why don't you go ahead and pause the video, and after you're finished, you can press play, and then you can double check to make sure you did this one correctly. All right, what you should have done is we had the relationship 0, 0, right? So with 0 pieces of snacks, right? Then you would have 0 calories, obviously. 1 was 5. 5 would go right here in between the 4 and that next line would be the 6, right? 2 and 10 would go right here. And 3 and 15. So 3 and 15 would go right about there. Okay. Now, if we drew a line through it, again, try to draw it as straight as you can. So a couple things underneath describe the relationship. You would say it passes through the origin. Through the origin. And the next thing is that it is a straight line. And if both of these are true, we know that it is a proportional relationship. So those are the things that you should have written down to describe the relationship of this graph. All right, now you're going to go ahead, flip the page to page 33. Starting at the top, we have example number 2. Again, same type of situation except different information, right? So let's go ahead and graph this relationship first. We do start out with 0, 0, so it does pass through the origin, which means that there's potential for this to be a proportional relationship. The next point was 1, 8, so we'd go over 1 up to 8. The next point is 2 minutes, and feet is still 8, and 3 would be 15, which would be graphed right there. So if we connected these dots, we would start at 0, 0, go up, across, and up, just like that. So in part B, where it says describe their relationship, it does pass through the origin. Passes through the origin. However, not a straight line. And if it's not a straight line, that means it doesn't go up at a constant rate, which means it is non-proportional. All right, so hopefully that kind of makes sense. Again, yes, it did pass through 0, 0. Now, here's the other thing we need to talk about. On the last slide or the last example, we talked about this point 1 comma r. Now, that only matters when the relationship is proportional. So this is not considered the unit rate because there isn't a unit rate when it's a non-proportional situation. So just keep that in mind as well. All right, so let's go ahead and move down to the check. All right, again, just a little further down the page, on page 33, here's the check. If you would please take a look at the table and the situations talking about the balance in a savings account. Let's go ahead and graph this, describe the relationship, and decide whether this is a proportional or non-proportional relationship. Go ahead and stop the video. Go ahead and go through this, and when you're done, you can resume the video and make sure your information matches up with ours. All right, let's graph these points. We have 0, 10, which would be right here. 1, 12, which would be right there. 2, 14, and 3, 16. If we connected those, it would go just like this. So, if we describe this relationship, you should have said it is a straight line. It does not pass through the origin. Pass through the origin. So even though it's a straight line, it doesn't go through the origin, which means this is a non-proportional relationship. All right. So, again, now today we went through two different examples, referring back to the I can statement. This is looking at graphs to see if the situation is proportional or not. And hopefully what you learned today is that in order for a graph to be proportional, it has to go through the origin and it has to be a straight line. All right. All right, the last thing in this video, if you would, we're just telling you what your homework is, right? So on page 39, we only did the first two examples, and that's the only thing as part of your practice on page 39 is problem number 1 and 2. So go ahead, do number 1 and 2, and you'll check this in class tomorrow with your teacher to make sure you understand the concept, again, of graphing and if it's a proportional situation or not. Once you are finished with the homework, go back into Schoology and check out what tasks 3 and 4 are as well. All right.